really bad video with really bad quality, and I don't care. It's just convenient. It's the living room, laptop, tablet, bad lighting, other stuff's upstairs, and it's a short video. Is it really? So, what is it, aside from another slightly man-cap idea that may or may not involve clones and possibly dancing midgets? Don't ask. The premise is to build a sensor to fit atop a fermentation vessel in line with the blow-off tube, realistically, to effectively try and work out if fermentation is finished without ever having to actually open the vessel or, lose, walk through taking samples. Keep things cleaner, cut down on losses, and generally to provide a better way of doing it, hopefully. So, yeah, that's the idea. Button! Pretty good correlation as I've expected. I will add the actual graphs into this video when I edit it, or editing me will, assuming I feed him. Did I feed him? Did I leave the gas on? Is he dead? I don't know. Questions for later. Questions indeed for later. The general correlation was as expected. As the fermentation kicked off, very little airborne alcohol. It peaked, slowly started tapering off. What I wasn't expecting was that the overall level for both, even when I was tracking CM2, the overall level stayed higher than the base levels. I was kind of initially expecting it to drop down to basically where it started because there'd be nothing kicking alcohol in the air, but on reflection that was probably a bit of a daft assumption because you are pressurising the system, and even after you're not pumping more CO2 into it, you're going to attain a level of equilibrium. The alcohol is still going to be airborne. You open a fermenter, you can smell alcohol, it's airborne. So that makes sense. One of the fundamental points of looking into this was not actually focusing on the actual alcohol level. What we're actually reading is the voltage level from one of these sensors, which relates to the alcohol level, like you convert it back to parts per million. But for the sake of this, it doesn't actually matter. It's additional work. There is no need for it because what we're actually tracking is the change. So we're seeing the data go up, we're seeing the levels rise, and then we're seeing them start to kind of plateau and even out, and that's what we're actually looking for. The one change I might make with the later version is actually adding a pressure sensor, because I might be able to pull in some information and correlate the two. That's the fun part. I'm still trying to figure out the exact way of doing that. That's the how, well, the result even true. And now I should press the button again, because I'm going to add little cuts between this. You've probably seen this by now, and I would have edited it, and I'm essentially just rambling like a madman. Button. Muffin button. The question of what I'm running it on. At the minute I'm running on a series of Wemos D1 clones because they cost nothing and work rather well. I'm not using the inbuilt AD because depending on different versions, you've got 1.1 volt or 3.3 volts, and then you've potentially got external hardware for that, and no one can actually come up with any real meaningful answer as to what a particular board is giving out. Later down the line I might use, well, I've got some ESP12 modules, and I'll most likely build a board for those, in which case I may be using the internal AD. At the minute I'm using an ADS1115 unit. The other reason I'm using that was because initially obviously I was monitoring CO2 as well, which meant I required two inputs. The actual range on that may be far more sensitive than I need. It's a 16-bit AD. The 10-bit internal AD is probably going to be almost perfect for that. When I come back to pressure sensors, not so sure. At the minute it's running some custom code, unsurprisingly, that's fundamentally going through recording the data, submitting it to an MQTT server, which is saving it to a file on my server somewhere, so that I can come back later and look at it. Also knock up some funky graphs with no red. And there goes my train of thought. Wibble. I may also add logging to SD card later on down the line. because that could be useful for people without it. One thing I do want to attempt to do is have some kind of visual indicator. At the minute I've got an SSD 1306 screen on there. In fact, I've got one of the little 128 by 32 ones actually showing the change values. I want to try and get something more meaningful. I've also got a WS2812B array of 8 LEDs, and I'm trying to use it as a bar graph to represent change, but with the data I've got, trying to find a way to quantify it in a meaningful way is proving troubling. Statistics is not, give me a hard number, brilliant. Give me wibbly statistics, no, not my thing. But I'm still working through that, because I would quite like to be able to show just a bar graph that says, this is the rate of change, but it needs to be relative to the overall progress, so not just rate of change over a small time, because you've got effectively useless data then. I could do this by working out a realistic maximum and then going back from there and effectively saying this is what's likely to be, here's the rate of change relative to that, but again I'm not sure that would give me what I want, so I'm having a look into things, picking a few friends' brains. It's handy having people who work in wind tunnels and do stuff like that, because they know about figures and things that give me headaches. I did initially try running off of batteries. In fact, the first test ran entirely off of a rather big power bank, but even with that, there are kind of obvious glitches in that set of data where I had to change batteries, because these little things have a heater. The heater is a 5 volt device, it's on all the time. I contemplated turning it on and off, having an optical isolator or something like that, just switch it, or even just a read I should say. But there is a warm-up time, and the information on warm-up time for these sensors is a bit out there. The figure on the datasheet is 48 hours, but it's not clear whether that's 48 hours for reliable accuracy across the lifetime of the sensor, so an actual burn-in time, because it is listed as such, or whether it's per read. Per read seems unrealistic. For a burn-in, it makes sense, because it's heated sensor, it's going to change after a while, being heated continuously. It's going to settle, and that's the other big thing. So I'm leaving it on all the time. Even if I didn't, I would bring it up 5 minutes ahead of time, so that you at least get consistent readings in the context of what you're doing, because that should still work for that. The other question I need to find out is whether I can run this off of 3.3 volts for reading. They are by design a 5 volt device, but there are two separate sets of connections for heater and reading. The read is actually just resistive, from everything I've read up, which is again, data sheets on these are a bit wibbly. So I should be able to run the heaters off of 5 volt, but run the actual resistive element off of 3.3 volt, and then add another resistor sort of divider accordingly, so that I get results I expect. Gonna find out. Another test. I've got 3 of these to go in various other bits and bobs. But so far, the data is showing a good correlation. The firmware is working as I'd hoped. I've made a number of tweaks in the first version. On every read, I am reading 3 times with a 10 millisecond delay, just to make sure I get a nice average for that. But now I've effectively implemented a major and a minor read period, and the minor read period will be over the major read period, so you'll have a number of samples over that period. In this case, it is an hour, and then 5 minutes. Then every 5 minutes it takes a sample. When it comes to submit data to the QQT server, it averages out. So over the hour, you have an average change based off of all of those readings. So that has given us some nice, smoother, I don't want to say smoother, easy to interpret data, but it's less jumpy, more consistent, and seems to give us better results so far. Now I press the button. Button. What next? What next? What are we doing next? What's anyone doing next? We've got Brexit ruining the country, the world's going to shit. Look at Trump, look at his hair. It's grown on the beach somewhere. It's like a coconut thing. It's not real. It can't be real. There's no way it's real. Yeah, what next? More readings really. I have some half-inch BSP T-pieces and various other things. I was trying to 3D print a thing for this, because so far all the stuff has been 3D printed, but I'd rather do this as off-the-shelf kit for repeatability. And I was trying to effectively print a threaded half-inch BSP insert to go into the pipe that would hold this. This is 17.4 mils you need. The inside of a half-inch BSP pipe is about 18.7 mils, so the wall thicknesses were very thin. Not overall, because it was a thread, it was where the threads cut. And in order to print, I had to have it so that the threads were going up, it was sat that way on the printer, which meant the layers went down like that, to get the threads as clean as possible. Downside of that is that's the weakest direction of strength to 3D print that kind of thing in. So when you thread it in, the threads effectively cut through the layer lines, and most of the threads turn into amusing springs. Very consistent springs. I may have inadvertently found a very good way to make 3D printed Zebedees. So, boing, basically. But a friend of mine had the very obvious idea of why not find an existing bung and drill it out. I was looking at getting one machined. I put feelers out for costs. But yeah, that could work well. But I've actually had the thought since then of rather than have it machined, why not do both? Have an insert for that. It doesn't have to be threaded, it just has to be big enough to hold this and get past the threads. So I should have enough room there for that. And I found a half-inch to 1/4-inch bung. So what I can then do is use the 1/4-inch bung with cablated, so there should be hopefully no machining at all required on that, which will make life a lot easier. And again, off-the-shelf parts, aside from a couple of 3D printed inserts. The other thing I want to add is a pressure sensor, and that's proving fun. I've worked it out. The average pressure inside is going to go up to maybe 35 psi. Looking at people who do forced fermentation under carbonation, the highest they go is 2.5 bar, because at that point yeast starts going bad. It doesn't work anymore, so people stop at that point. That comes in around 40 psi. Realistically, if we're not looking at fermentation under carbonation, that kind of thing should work. So that's about I think it's 250 kilopascals. The problem is finding a sensor that isn't either way too small or way too big. If anyone mentions it, yes, there are the BMP 280 sensors, but they are barometric pressure sensors, so they effectively work backwards what we want. They are calibrated to effectively be at around 15, because they're for measuring distance above sea level, so they are calibrated to be around 15, 14.7 I think it is, psi at sea level, and then you go up to 0 and then down below that, but they don't really work in that range. They're not adequately sealed for my liking. I mean, that I would still prefer more of a mesh on, but in the event of a blow off, that should still probably be fine. So I'm looking at, I've seen on AliExpress some 1/4-inch gas sensors. They're a bit vague, they are resistive. I would have preferred some digital, because I just don't want to be dealing with too many cables and then extra potential issues with noise on the line, but at this point it's probably not a thing. It does mean I would be sticking with the ADS 1115, unless someone knows of a dual channel AD that's easy to use like that. But otherwise, it's not massively expensive. In fact, I've got some tiny little 8-pin dip ones as well, which will probably work wonderfully for that. But again, there's 2 channels and they're not being used. I've got no intent of adding any more sensors than that. I may add temperature sensing, but I wouldn't be doing it with an analog one. I'll be doing it with a 2-wire digital sensor, because they are reliable, they are easy, and also they are available in ready sealed units for use in liquids and in that kind of environment, so it makes them ideal for it. Some of this is a bit off. I'm not working at the minute, so it's kind of with what I've got lying around. Luckily I do have a load of these sensors lying around. Only one MQ3 till recently, that just arrived in the post, but great big pack on. I think everyone who's ever had an Arduino probably has one of these packs, because they go cheap now and again, and they've got loads of little interesting gas sensors in, so buy them. Yeah, aside from that, it's just a case of testing and testing. I mean, my current test fermentation vessel, because the first test I did a small 10 litre batch, because I'm growing for that size, because I use little mini kegs at the minute because space. Is a 2 litre Coke bottle with a 3D printed lid with everything attached on it. So it's got a 3D printed lid, sensor access port on the side that goes into, and a bulb on the top with a half-inch tube going off into a blow-off jar. It works. I've got what's just finished fermenting with Nottingham some sugar water. I've half tempted to try and taste it. I just wanted it as a control. So it's 200 grams of sugar in 1.5 litres of water, kept in the same place, not moved around, not fiddled with, powered continuously this time, so there are no little blips in there as I was looking at with the other one, which all pretty much coincide with me changing batteries. And then of course messing up the reading on the sensor. So I'll be continuing to test that way. The next unit, the one with the half-inch pipe T-piece, will be inline, so it'll be a bulb either end, sensor in the middle. If I get the gas sensor, it will be tapped through the side. The other option is to actually go for a four-way connector, but it's getting into bulky, clunky areas there, and I'd rather avoid that. So drilling and tapping the side seems to be a better option for that sensor at least, and that will hopefully give me some better results. The pressure sensor may be completely useless. I may just end up going purely with the alcohol sensor, but I figure that changing pressure may also be worth tracking alongside changing alcohol levels, and that may give us a better overall indicator of yes, this is done. So fundamentally you would run for your fermentation, you get the green light and you'd say okay, out comes the hydrometer, then you do your final test. If you really want to be anal, leave it a day, test it again, but you're not doing it 4 or 5 times. You're not wasting 200 mils of water and or beer. At what point does it stop being one and become the other? For the sake of testing, and you're not risking infection every time you do it. I know that most people's sanitation practices are fairly good, and you know it's still a risk. And if you can avoid the risk and keep the system completely kind of closed until you need to open it, then all the better. Plus, if you're sitting there looking at, submitting data to an MQTT server, you can monitor it remotely, so you don't even have to be in the same room. Just sit there and get a little indicator on the dashboard that goes, this is done now. Stick it in a keg, wait for it to carbonate, drink and be merry. Ready. Anyway, that's it. Adios, boys and girls. And if you do happen to see a little tiny ninja gnome clone of me that looks like it might be slightly broken, ignore it.